Hello, this is a section 7.3 lesson. In this section we're going to talk about a couple of ideas. First we're going to connect the idea of ratios and fractions, and then second we're going to talk about this idea of cross multiplication. We all know and love cross multiplication. We know how to do it. We're going to talk about why cross multiplication works and what it is we're really doing when we cross multiply. So to start off with, let's look at this scenario that we first saw in section 7.1, where a muffin recipe calls for 7 cups of flour and 2 cups of milk. So we have this relationship between cups of flour and cups of milk, so we have a ratio. We said that we could describe this ratio in 3 ways. First we could describe it in words, and then with a colon, and then with a fraction. So we first want to talk about is why can we use a fraction? How are ratios connected to fractions? So let's try to justify this with a simple problem dealing with this scenario. So same muffin recipe, ratio of flour to milk is 7:2, and now suppose we have 3 cups of milk. How many cups of flour do we need? And we're going to solve this in 2 ways. First with a ratio table, just like we have been doing, and then second with cross multiplication. So to solve with a ratio table, let's draw our ratio table, and we'll put in our original ratio of 7:2. And so we need 3 cups of milk, but in order to go from a 2 to 3 directly, we'd have to use a somewhat nasty fraction. So let's go through 1. We're going to put a 1 there in that column. So to go from a 2 to 1, let's multiply by 1/2. And so we're going to have a 7/2 here in this cell. And then to go from a 1 to 3, we're going to multiply by 3. And multiply 7/2 by 3, we're going to get 21/2. So there's the answer to our problem. We're going to need 21/2 cups of flour. So fairly simple problem. But let's make an observation here. In that ratio table that we just set up, in one column we had the ratio of 7:2. In the next column we had this ratio of 7/2 to 1. So those two ratios are equivalent. So this right here, we're starting to see the connection between a ratio and a fraction. So this equivalence, or this second ratio of 7/2 to 1, means that 7/2 cups of flour is going to go with 1 cup of milk. So this fraction 7/2 is called a unit rate. So now let's go back to this same example and let's solve it with cross multiplication. So to set up a cross multiplication problem, we're going to set up 2 fractions that are equal. And this first fraction on the left is our original ratio of 7:2 in the form of a fraction. And then on the right, we're going to put our cups of flour on top and our cups of milk on the bottom. In this case, we're given 3 cups of milk, so we're going to put 3 in the bottom. And we don't know the cups of flour, so we're going to put a question mark there in that numerator. And so we're going to set these 2 fractions equal to each other. And remember that when we set 2 equivalent ratios equal to each other, this equation is what we call a proportion. Now next section we're going to talk more about proportions, but this is what a proportion is, when we set 2 equivalent ratios equal to each other. So now let's get rid of all the labels here and talk about how to solve for the question mark using cross multiplication. So of course we are going to cross multiply like this. You can draw arrows there if you want. On the left we're going to have a 7 times 3. On the right we're going to have a question mark times 2. And then in the next step we just do this multiplication on the left. We get 21 equals question mark times 2. And then we want to solve for the question mark, and so we denote this by we're dividing both sides by 2. And so the 2 on the right cancel off. And we have 21/2 equals question mark. And so there's the answer to our problem. We need 21/2 cups of flour, which is the same solution that we came up with using ratio tables, just a different way of doing it. And so that's how we solve a problem with cross multiplication. And so the next question that we want to ask is, why does this work? and what are we really doing in each of these steps. So to answer this question, why does this work, let's solve this problem in a slightly different way using tools that we already know how to work with. So here's this original proportion, and let's do this. These two fractions have different denominators, so let's get a common denominator by multiplying this left by 3 over 3 and this right fraction by 2 over 2. And so what we're going to get on the left is 3 times 7 divided by 3 times 2, which is 6. And on the right we're going to have a question mark times 2, and the denominator is going to be 3 times 2, which is 6. Now these two fractions are equal. Well, the only way that two fractions can be equal is if their numerators are equal. And so this tells us that 3 times 7 has to equal question mark times 2. Or do the arithmetic. On the left we have 21, on the right we have question mark times 2. So now we want to figure out what is question mark. So here we have a multiplication equation, and so let's convert this over to an equivalent division equation. So let's go over here, and so this multiplication equation is equivalent to 21 divided by 2 equals question mark. So that's the equivalent division equation, and that comes from the very meaning of division. And so now we can write this from what we know about division. This left-hand side is equivalent to the fraction 21 halves equals question mark. So there's the same answer, just using different techniques. We use the idea of equal fractions having equal numerators. We use the idea of conversion between multiplication and division. And so next, let's kind of compare these procedures and make some and note some similarities. So we did cross multiplication. Right, we started off with this proportion. We cross multiplied, and this is what we came up with. And then we divided both sides by 2. And then on the right, the 2's canceled, and we're left with just question mark, and so there was our answer. Now in the second approach, where we got a common denominator, we took this original proportion here, multiplied by 3 over 3 on the left, and 2 over 2 on the right, and we got this equation, and then we set the numerators equal to each other, did the arithmetic on the left, and then to solve for the unknown, we converted from multiplication over to division, and then we converted basically from division over to a fraction. Okay? And so let's note some similarities. Specifically, note these two steps right here. Those two steps are basically the same. When we cross multiplied over here, that's the same as what we got when we set the numerators equal to each other. Now over here, when we divided by 2, that was basically equivalent to converting to a division problem, or converting from a multiplication problem over to a division problem. And then of course the last steps are the same. So 2 points here I hope that we note. Number one, that cross multiplying is what we get when we get common denominators and set numerators equal to each other. So cross multiplication is really just a shorthand way of getting common denominators and then setting the numerators equal. And then the second thing I hope we observe is that when we divide both sides of an equation, that's really equivalent to converting a multiplication equation to a division equation. So this idea of cross multiplication is just a shorthand notation, or short way of doing things that we've talked about. Setting fractions equal to each other, converting between multiplication and division. It's just a shorthand way of doing all that. Our last example here is going to be a problem that we'll solve with cross multiplication, and this is going to involve an improper fraction. Excuse me, this is going to involve a mixed number. And in order to solve this, we're going to convert it over to a mixed number. So a recipe that serves 6 people calls for 2½ cups of flour. How much flour will you need to serve 10 people assuming that the ratio of people to cups of flour remains the same. So notice that we have this relationship between number of people served and the cups of flour, so we do have a ratio. And so we want to make a bigger batch in order to serve 10 people. Question is, how much flour are we going to need? So let's set this up with as a cross multiplication. So we're going to set up a proportion. We're going to take this original ratio of 6 people to 2.5 cups of flour and set this equal to 10 people divided by the unknown cups of flour. Now don't let the fact that this number over here in this denominator is a mixed number scare you. It's just a number. So let's solve this. We'll get rid of our labels here so things don't get so things look neater. And so we're going to cross multiply. On the left we'll have 6 times a question mark. On the right we're going to have 10 times 2.5. Now on the left there's really nothing to do here, so let's just write that 6 times question mark. On the right we need to do this multiplication. Well, in order to do this multiplication, let's convert this mixed number over to an improper fraction. So 2.5 as an improper fraction is 5/2. And now we can easily do this arithmetic on the right. Multiply numerators, 10 times 5. Well, actually, we can simplify this a little bit. The 2 and the 10 will cancel off, and so we're left with 5/5. And so this is 25 on the right. And so now let's solve for question mark by dividing by 6. Divide by 6. And so we get that question mark is equal to 25/6, which is an improper fraction. If we convert that over to a mixed number, we're going to get 4 1/6 cups. So there's our answer. In order to serve 10 people, it's going to take 4 1/6 cups of flour. So what I hope you get from this example is that when we're working with a mixed number like that, in order to do the arithmetic, first we want to convert that over to an improper fraction, and then that's going to simplify the arithmetic.